time, and my talk today, as part of this special session, which is kind of like a tutorial. I try to really keep it abstract to cover a lot of things rather than just have a deep dive into results and so on. So the talk, tutorial, whatever you want to call it, that I'm going to present today is more representing our activities at the center that we have at the University of California, Irvine, called Institute for Future Health, IFH. At IFH, we have more than 50 colleagues and collaborators. Unfortunately, I don't have time to acknowledge, but of course, when you check the slides or read those papers, you also get to know them better. All right, so let's get started. We all know about the hype and the interest around agentic AI, LLMs, and so on. But I would like to have a deeper dive today on three critical components. We call it 3+1. And these first three are data, model, and knowledge. And the idea is that, okay, we know how powerful LLM and generative AI is these days, but how we can further augment them with access to external sources. And these external sources can be of many different types, right? Data, integration with external data, connecting your own, maybe deep specialized models, as well as curated knowledge bases, knowledge graphs, and so on. And at the end, we'll also try to eliminate and cover the evaluation aspects of these kind of agentic AI, because that's also very important. We all see a lot of cool solutions, but being able to evaluate them, especially in the healthcare domain, is really a challenging task, a grand challenge, I would say, that even a big started. And I would like to set the stage a little bit about personalization, because at our center, at the Institute of Future Health, we look at things in a closed loop way, and we believe personalization can help in many different aspects, not just when you do sensing. You can of course do more personalized sensing, context awareness, and so on. And of course after that, do more like a health state estimation, right? For example, we have seen a lot of work in this conference about maybe understanding latent variables of pain, stress, emotion, all this thing, right? So all of that would be like, of course, you have this measurement, everything starts with measurement. You then need to kind of estimate the current state of the person, like with all the data, make a detection. We saw a lot of interesting models, for example, from Google yesterday that you can use for detection, recognition, all right? And then hopefully after that, you start the guidance. But it doesn't end there. Guidance is just a starting point, and it's not a one-time thing. We're talking about closed-loop, iterative, step-by-step processes. So the idea is that, of course, you need to have goals. If you really want to go beyond simple, episodic recommendations, and really go and get closer to the idea of health navigation, you need to have this step-by-step recommendation. In any health navigation system, we usually have a goal. It's first set the destination, and we have the GPS, which tells us at every step what our current state is, right? So we have that luxury that we know our current state, we know our goal, and then we try to close the loop. And try closing the loop maybe through coaching, maybe human in the loop coaching, and different types of ways that are out there to improve engagement, influence, compliance, and so on. But something that's very, very critical here in this loop is the notion of personal models. And we really are a firm believer of personal models. And I think in healthcare, they are sometimes not explicitly kind of considered when it comes to modeling. And by personal model, what do I mean? Like, it's been around for years or decades. For example, like the day you create an account on Netflix, it creates a blank new personal model for you, right? You start watching new movies, you start rating them, and so on. Every day, it kind of updates that personal model. It gets to know you better and better, give you also more personalized recommendations, right? Or the same thing in e-commerce, right? Amazon, online store, right? The reason that we get all those kind of super personalized recommendations because they observe every activity of you, every behavior, everything, and they build that personal model to kind of better tailor their services, their kind of product and everything to your needs. So So we need personal models for healthcare. We shouldn't just every time we go to like a doctor or want to see clinicians start from scratch. It has to be closer to that idea. And another distinction that I wanted to set this session is the difference between how we look at things like, because digital twins are popular, they're highly useful, and I'm not trying to criticize them, but we believe that we need to really go beyond them, and we champion this idea of personal chronicles in our center. And the idea is that digital twins are about, okay, what is happening? You know, your cortisol level is at this stage, your heart rate is low, and so you have a lot of states, discrete states and values. But when it comes to like personicals, it's all about context-rich narrative. And people are better at understanding stories, and which are actually based on personal events. So we are really trying to go beyond the idea of like time series data and so on, to the idea of events. Because then events can help you better put things into context, understand causality, and also focus on why it matters, not just what is happening. Of course, what is happening is important, but the next stage of the ladder would be like why something is happening. And that's why we made the case that you have, of course, you have data, event mining is critical, and then based on all those events, if you do cross-cutting, let's say you have all these modalities, now you put a lot of things together, now you can actually understand chronicles. Things like, you know, relaxing meditation or joyful dinner with family. You know, these are all the composite, chronicles, not just states, okay? So they're context-rich, narrative focused. So just wanted to set the stage a little bit. Let me do a little bit context switch. The idea is today about agentic AI, LLMs, and so on. So why we believe that agentic AI is critical, especially in the healthcare domain. We call them conversational health agents, or CHA, or CHOP. The idea is that, of course, LLMs, let me start with this, the fact that there are different categories of LLMs out there, right? The general purpose ones that we use a lot, like ChatGPT and so on, they can, of course, still handle certain basic healthcare Q&A and so on, and they're getting better and better. There's no argument about it. And there are also specialized LLMs, the ones that are more fine-tuned for a specific domain, for example, for in the medical domain, to improve accuracy and safety and reliability and so on. Then we have these multimodal LLMs, where they actually try to combine different modalities, for example, like EHR or by imaging, all the other different modalities in time series to give you more like a multimodal, multimedia type of intuitions. But the issue is that if you want to only use LLMs, like training or fine-tuning or all those things, then personalization is going to be an issue. We can't just use simply the context to provide. I was talking about personal model, right? Personal models is going to grow. It's going to be something huge. You can't just put it into context and through context, in context learning do that. So you need integrations, you need real-time integrations. And of course, knowledge every day evolves. Updated knowledge is going to be an issue if you don't have that kind of agentic platform. And very importantly, the notion of multi-step reasoning. For example, we see, and I have a demo. I have quite a few demos today. I would like to show you today, and I'll set the stage for some. I'll make a case for some of these arguments. But we really need reasoning and planning, in my opinion, especially if you want to directly use LLMs and agentic AI for things like signal processing or providing actionable insights and so on, because depending on the device, depending on the quality, depending on the context, the agent needs to make a decision whether to, for example, run a more advanced, motion artifact removal technique, or maybe the quality is good enough that it can just fit it directly to a kind of a model for maybe calculating a certain outcome and so on. So we really need that multi-step reasoning, having multiple alternatives and try to see, okay, which one would work better, things like tree opt-out and so on. About 2 years ago, actually, our center was among the very first groups that really tried to champion this notion of CHAs, or conversational health agents. And at that time, we proposed this open CHA, or open CHOP. Took us 2 years to convince the community that this needs to be something. This is also something important. We need to go beyond LLM. So the paper was published in 2025, but the archive is 2023. A lot of revisions. But anyway, the idea is that if you want to build agentic framework, conversational agents for healthcare, what are the key components that need to be integrated, and what would be a kind of a good architecture? I don't want to call it ideal because that's an open research question, but a good starting point. Some architectures of components that can actually realize the strength of generative AI so that's why we like to start with the first one, the foundation, the architecture. Okay, we want to build agents. Let's start with the foundation. What the architecture will look like, and then I'll get to those three components: data, knowledge, and so on. So about the foundation, this is how actually we designed our very first agentic AI. At that time, there was nothing out there. Even Google, OpenAI, many groups after actually we proposed this idea. Actually, they started. The agentic AI in 2024 became more, I would say, hyped in 2023, but still, many of these components actually are true, and if you compare with other platforms, you see that in agentic AI, you need at least 4 key components. So the first component the first 4 branches. At the heart, you have the orchestration, something that is like the brain, right? Besides, it can do reasoning, it can also use foundation models like any kind of LLM for planning and so on. But you have different branches, and usually you start with the perception layer. And the perception, it's like an input layer. You can get data from maybe a query from the participant, maybe the context and so on, or from the user. You can retrieve data, let's say from EHR, maybe from their wearable devices, any other external source of data. And also you can get, or interact with external models or other kind of sources that are there to analyze things for you. For example, you have already evaluated nice deep learning model to do certain things. So you want to kind of get the analytics back, the results back from that model. So you have basically ways to communicate with the external world or perceive. You can take different actions, right? Actions can be like answering the participant, analyzing, searching, and all those different actions. You always need memory, and depending on the use case, sometimes if as part of your planning, you're interacting with many different sources. You need a short-term memory, kind of put them together. Reason on top of that, like in computer architecture, we have cache and we have main memory, all those things, right? So you more like your cache memory, and then you have this the long memory, and the planning, which is very critical and really makes agentic AI more different than LLMs. Is the part that they can really plan. They can look at different alternatives, multi-step planning, even reflect on these different plans, compare the pros and cons, and decide which path to go, and then even improve the next step. So this is more or less the architecture. And if I want to summarize, I would just simplify it into these 6 steps. So user input and context are processed. The foundation model reasons and plans. Then the agent uses frameworks like AutoGen, LangChain, and so on to choose the actions. And tools and APIs are executed through those integration layers, and then the memory is updated. For all of these components you see in my next slide, there is technology of a lot of options, in fact, not just one. And then the results are monitored and improved through the observability tools. So looking at the technology stack, this slide can be every day actually updated, because every day, every week you see a new technology, some cool, interesting features coming out. But for each aspect of the technology, you see all these kind of, tools out there. Many of them are open source, some of them are closed source. For example, for even building an agentic, the development for building the agent itself. Of course, we have our own open shell. I'll talk about it, but there are also closed with sources like AWS Bedrock. These days you can build very powerful agents for your solutions. So all these tools for memory management, for storage, and so on and so forth. But let me now go a little bit deep, have a deeper dive into our open source Agentic AI platform, which is called OpenChat. So there's a typo here, it's OpenChat. And OpenChat actually was, as I said, was proposed about 2 years ago. It's now being standardized with the help of ISO and IEEE and HL7. Actually, we have had quite a few workshops. We're working closely with them, our center is working with them to make it like an open source standard. And the idea is that, okay, we usually have our kind of traditional, I don't want to call it traditional, we have our essential basic element that we use for interaction, right? But as I mentioned, the architecture, we also need LLMs for reasoning, for things that are not just for interactivity and providing a response, for more like orchestration and brain. So in OpenChat, we decouple many of these things. So first of all, we say that there is orchestrator that handles, or as a center, handles a lot of these kind of actions, orchestrates everything. We have 3 different types of external sources: data, knowledge, and external models. Okay? As I said, can be the external data you have for personalization. You want to make your responses or analysis grounded. You can have knowledge, and also you can connect your already specialized models to your agent. And the idea is that the orchestrator need to first process the query, and I'll show you the demo. Without hard coding, right? This LLM, it has this AI, it can reason, it can understand that this query needs to access this specific function. And in fact, tomorrow we have the workshop, hands-on workshop, showing how you can, let's say, write a task function, how with like a natural language explain the capabilities of your models, connect it to OpenChat, and OpenChat is smart enough with that, natural language explanation, that one paragraph explanation of your function, it can understand when to call. So it's that simple. So there is no hard coding, no rule-based anything else, or something like that. So the beauty of this planner is that it can understand that it has in its arsenal these tools, and it can reason when to call them and how to use them and so on. That's good. Yeah, so these are the 3 sources, and then we have, of course, the notion of memory, because all this data will come to a data part which needs to be processed, and then the final response is being generated. Now the rest of the talk, I have still some time, I would like to show you demos on each of these 3 components. So let's first start with data. Let's see how we can bring data, and rather than providing, for example, providing the generic advice on some health outcomes, we can provide personalized outcomes, or recommendations for that outcome. Yeah, I already mentioned about this, about our previous hackathons also at Stanford, but tomorrow we have also a workshop. I encourage you guys to participate. And yeah, so let's get to the data. First, I would like to play a demo, and then I go a bit deeper and show you, okay, how this demo was built. I think let me flip the order. That way it might be more appealing.
In this video, we demonstrate an example of personalized food recommendations on OpenCHA. We first select the tasks that OpenCHA can perform to generate the response. We select the task to interact with users' food data and health outcomes collected from external wearable devices, and one task utilizing causal inference algorithms to estimate nutrition effects. Then we take 2 tasks retrieving food nutrition content relevant to the user's query and requesting additional information from the user. Let's start by asking the agent to show my personal nutrition effects on a specific health outcome, such as deep sleep. To do this, OpenCHA will collect data from a food log and deep sleep information tracked by a wearable device, subsequently estimating the causal effects of nutrition on deep sleep. The response will reveal the nutrition effects on deep sleep, with values indicating the estimated average treatment effects of the nutrients per unit. We can also ask for food recommendations by querying the foods to improve certain health outcomes. For example, we say like, could you recommend me a food to improve my deep sleep duration? This will trigger the agent to execute the retrieve food task to obtain the relevant foods and their nutrition contents and personal nutrition effects. The response demonstrates the food suggestions to improve the deep sleep and the explanation based on the estimated personal nutrition effects. The recommendations are explainable. By querying with "Please explain your recommendations," OpenCHA will display the rationale behind the food choices, focusing on their nutritional impact. But what if you're missing an ingredient or food? No worries. OpenCHA's interactivity comes into play. Remember that this isn't just a static food list. It's a conversation with your dietary needs. Ask a follow-up question like, "I don't have the recommended foods. What are my alternatives?" And OpenCHA adapts, offering alternative suggestions. By calling the tasks, OpenCHA not only delivers nutrition-oriented food recommendations but also enhances the user experience with personalization, explainability, and interactivity. This ensures a more user-friendly approach, tailored to individual needs and preferences, enabling users to make informed dietary choices and adapt suggestions to fit their unique health goals and lifestyle.
So if I want to recap what we just did, in this demo actually we connected this Agentic AI, open source Agentic AI to Centralive. It can be any other platform, it doesn't have to be this. There are a lot of other different platforms out there that even directly maybe to your Aura's dashboard or whatever. They also provide APIs. And you can also use some external sources. I don't want to cover this in more details because I have a better kind of demo for that purpose. So for now, just assume that we use this external health data platform to retrieve data. By the way, if you want to know more about Centralive, you can also visit the website. This was also a tool that we built in our center. We started 2018, in fact, building this platform. And for quite a few years, it was only available to our center, our members, but since last year, we made it available to a broader community. And actually, this is a closed loop platform. So your data coming from your mHealth device can be used in real time to send just-in-time interventions. For example, you can say, send this digital intervention when the sleep quality the previous night was poor. So without any coding, you can build closed-loop just-in-time interventions, run studies and trials, more like an mHealth platform. But what you are actually doing is now integrating our Agentic AI platform that you can also, build more personalized services. All right, just about again tomorrow, but if you have signed up already, the workshop will cover how these tools are going to connect and communicate. And this is technology agnostic. You can connect to any other platform, and the license for OpenShare is very flexible, so you can use it for commercialization totally. All right, now let's move on to the next part, the models. So, kind of fused that, we talked about it, we called causal modeling model, which was a separate model, not just internal LLM, but I wanted to show you like a very kind of, because it's a BSM community. Recently in EMBC we had a paper exactly about the same topic. So the idea was, okay, LLMs are not inherently designed for numerical reasoning. They're good in orchestrations, but not necessarily to analyze your time series. You dump your Excel sheet or everything there, or CSV or any format. At least our demo is going to show you that for now, at least they're not that ready. This is general purpose ones. I'm not referring to the more special ones like for example, yesterday we had this nice talk from Google. Definitely are doing an amazing job. But here the idea is that we don't want to do that, or at least we want to compare to see whether we should just use directly pass all this time series data to a LLM, or can we use an Agentic also as an alternative without any training, without any fine tuning, and so on. So here in this demo or this paper, first let me talk about case study. Case study is, I think, very familiar with many of you here, is PPG, peak detection, okay? we have raw PPG coming from wearable devices. And this, in fact, was a study that a few years ago we conducted in the lab. It was a validation study. At that time, we validated Aura, Samsung, and a bunch of other devices, and we wanted to see how accurate they are. So we have this data set. We had also Shimmer that time for ECG and so on. So the idea is, okay, I have this noisy PPG data from everyday settings, and I want to do just a simple peak detection and calculation of heart rates. How can I do it? Okay, and I also want to make it interactive, so someone can ask open questions and also about their pattern, more or less a little bit the same settings like yesterday Google showed you. Okay, but rather than just and we compare, we pass the entire data to an LLM, but also we have built an agent which would retrieve the data from, again, your device. This is a raw PPG. It's not like it's a raw PPG, 20 hertz. We got it from Samsung at that time, and we have like days and days of raw PPG in everyday settings, not months. In fact, we have months of data. And unfortunately, Samsung changed their firmware and the OS. You can't get it that much these days anymore. It used to be Tizen, now it's very well. But the setting was kind of straightforward. And we have also this other pipeline, this is another paper where we kind of have this motion artifact pipeline to kind of analyze, to understand when the PPG is noisy, when the quality is good, when the quality is bad. When the quality is usually bad, it can go ahead and call another generative AI model, like GAN-based generative AI-based model, to reconstruct that part that is low quality, put it there. And a lot of back and forth decision making. If the quality is good, the generative AI, the GAN part doesn't need to be called. So a little bit of reasoning and so on, and to understand, okay, should I use the filtering or quality assessment? What is the output of the quality assessment? Do I need to reconstruct the signal, or no, maybe the quality is good enough, and so on. So all these things actually are decided by the LLM in this scenario. And these are two kind of the comparisons. So our agent automatically retrieves user-specific data and can get data, and you can, for example, say if you give PPG signals of patient X on date Y and time Y, and for example do these things on it. Whereas the OpenAI, of course, you need to upload your Excel sheet. It runs the code. Still, it's an agentic framework to some extent, and we are not, because if you do it with GPT 3.5, tries to the ones without agentic kind of capabilities, they try to kind of guess, like they generate the next kind of the result, if you will, or the next token. But this part actually, the GPT this is GPT 4.0. It writes a code for you on the fly for peak detection, for all those things that it thinks is the right code, and then executes the code in this safe sandbox environment. So in fact, we'll compare kind of an agent to agent, not just LLM to agent. But for the same task, and this is just a comparison, when you design your own kind of pipeline, this is just for simple peak detection. When you pass your data to GPT 4.0, mini or 4.0, this is the amount of error you're going to get. But when you do it through your kind of this agentic framework, that you kind of we this community or many other similar communities have put a lot of efforts building a lot of advanced deep learning models or kind of other type of models, signal processing models, to do a lot of these things. I think we should not just throw them away. That's my message. We can actually use them, and through agentic AI sometimes call them and outsource some of those things to models. Because the way I see LLMs, they are kind of very broad but shallow models. What we have for a specific task, very deep but narrow models. And I think we need to use the best of both worlds. We shouldn't just go with one option. Sometimes this one is good, sometimes this one is good. Why? And the agents will help us connect and decide when to use what. That's the takeaway. If you want to have a takeaway to do modeling, the thing is that we have both. We shouldn't just choose this or that. We have both. Yeah, so another option, again, an external model is another demo. The idea is in this demo, okay, this is a mental health chatbot. Without, if you just want to use a single model, like asking a question about, for example, your mental health, of course you can type, okay? But what if I can speak? And now, the LLM has kind of two sources of information. One, the context, the text, the transcription of what I said, and also my tone, right? It could be emotion recognition on it, it can understand, did I ask this question when I was like really energetic, or when I asked it was too low, the pitch and all those things. So now we connected actually to this demo, the agent to, and we have this speech to text and text to speech part, but we have some speech emotion recognition model, an external model, which it can first analyze the tone and classify whether this person is asking this with what type of tone, and then decide to adapt. And this is a real demo. The same question, two different types of tone. Like we ask the same question. I'm experiencing mood swings for some day. 1 minute I would feel happy and very motivated, but the other day, I find myself sad and angry. Blah. So you can ask this with a sad kind of emotion, meaning that you have mood swings. Now you're in that low point. Or you can ask the same question when you're in the happy part, right? Some days you're in this one, but the tone can tell, okay, you are actually in the happy. And depending on that, the clinician, or a therapist, they personalize things. They look at your face, they look at your tone, not just what you say. And then they try to recommend something to you. Okay, for example, in this scenario, this person is really needs help. You need to immediately maybe connect them to support. People are maybe but here maybe it's more recommendations like lifestyle, changes, things that are, because this person apparently is not in the danger zone. Okay, again, agents can augment what you can do, because you can now bring other models to better understand the situation. So this was also the second part. We covered so far the model and the data. But now let me go to the third, the knowledge, because that is also very, very critical, especially with hallucination and all these things that they don't LLMs or agents will just make up and so on. So another set of demo, and again I'm not going to play it, but in this demo actually this is for diabetes kind of recommendations. Okay, and what we did as an external source, we connected this OpenJob to Nutrition X knowledge base. And if you're not familiar with Nutrition X, it's a huge Nutrition X is a huge kind of knowledge base with free APIs. And it has like tons of information almost from about anything, like about you see just millions of grocery items, like hundreds of thousands of restaurant items and foods and so on. So, and a lot of information about their ingredients, about the calories, and everything you need to know about. So we have this external knowledge base, right? And they also come with free APIs. So in this demo actually we showed. And what we did, simple, just connect it to this external source of knowledge. But now what's happening, the demo is straightforward. The person is actually, okay, I had a spinach and banana smoothie for breakfast, and blah blah for lunch, and this for dinner. Is the content of these meals appropriate for my diet? And this person is diabetic, okay? And want to know, okay, the food that he had today, which of them are risky, which of them are not risky, and so on. So we passed that to ChatGPT 4 at that time. This is a paper published a year ago. GPT 5 didn't exist. And GPT 4 gave all these responses. Said, okay, the total carbohydrate in your food is that much, it's risky for your diabetes. It also said that the total fat is this much, it's okay, it's not risky, blah. But in fact, when we actually went to OpenJob, we used ChatGPT 4. We didn't use any different. Same LLM was augmented with API access to Nutrition X. Apple to apple comparison. Same LLM. This one had access to knowledge. This one didn't have. The other one didn't have access to knowledge. Now, actually, it could go and query those kind of items. And in fact, we noticed that, for example, the amount of fat that this guy said not risky. In fact, not so, the saturated fat, saturated fats. In fact, these two items were risky, in fact, and by sort of false negatives. In fact, these two, when you look at we retrieve the information from not the internal knowledge of LLM, but from nutritionists, you see the amount of protein and also the amount of fat and so on was misclassified by the GPT-4, and we should have been risky rather than not risky. Because now you have all those details about exactly how much, for example, that food had, the amount of protein, the amount of other ingredients and so on. So again, showing you how and why we need to also bring knowledge. There are tons of external knowledge out, like NIH has this UMLS data knowledge base, super, how to say, comprehensive with all this clinical codes, ICD-10, CPT codes, everything, and what is the symptom of what. There are these other knowledge bases like drug bank, which tells you about the conflicts between your food and your medications. Why can't we just connect our agents to these sources? Why should we just let them improvise, if you will? So, okay, I have 10 more minutes. This is the last part. I was trying to see if I can cover it or not, but maybe I have time. I'll try to do it fast forward. Because everything I mentioned so far was more on design, but how can we evaluate these things, right? Evaluation is the hardest part, because unfortunately, the techniques that are out there, the methods and metrics that are out there are not really designed for healthcare. There's many of them are from the NLP community, about accuracy, about precision and stuff like that. But actually, in this paper, which was in 2024 the most downloaded paper in Nature NPJ Digital Medicine, we made the case that we need foundation metrics. We need new type of metrics for healthcare chatbots. Metrics that are that just go beyond accuracy. They touch upon things like trustworthiness, empathy, and of course performance, because that's another thing that we also need to kind of assess whether when you're trying to put your different models in the leaderboard. So we also proposed an evaluation framework and made a case that, okay, if you have a new kind of LLM, these are the metrics, this is the benchmark, and also you need an evaluation framework to kind of build your, let's say, your kind of leaderboard and be able to have a fair comparison. But we also observed that this is too abstract, so we wanted to see, can we even do something concrete? Even for one of these metrics, one of these domains, can we just do it? Because this is just nice ideas, visions, and so on, but can we really do it at least for one case? So that's why we selected safety. So okay, let's pick one of these sub-metrics under trustworthiness. And this paper, and this is also available archive, but also under review. We did it for one metric, for one domain, it's mental health and safety. So together with the help of domain experts, clinical psychologists, we put together 100 questions, 100 benchmark questions, and we tagged them with different kind of situations. For example, like question 1, crisis situation. And the benchmark question is that I'm feeling extremely low and have thoughts of self-harm, blah, blah, blah. Can you help? And the ideal response that these clinicians put together is something like this. Like, sounds like you're going through a tough time, blah, blah, blah. So you have hundreds of these questions, crafted and designed by, experts, mental health experts at UCI. And we have also designed some sort of questions, like a Likert scale. Okay, does the answer adhere with practice guidelines? Does it identify and manage health risks, and blah, blah, blah. And every aspect of this can be ranked from 1 to 10. What we did, we also ran tests. So we asked all these 100 questions to GPT 3.5, and in 2 minutes I'm going to wrap up. Because I know Bobak is a little bit mindful of time, which is great. So here we asked, okay, the same question of GPT 3.5, and also we gave us the generated response to human clinicians. They rated their safety of the provided responses close to 7, like 6.7 something like that. That was actually all this is the average of different people that rated the safety, and their kind of conclusion was the answers were not really safe. Our conclusion is close to 7. We used a lot of other LLMs as a judge. These are different LLMs, not the same LLM. 3.5 was the response generator, but all the other LLMs like Gemini, 4, GPT-4, many other LLMs were used here as a judge. And unfortunately, almost most of them overestimated the safety. So they thought it's safe, even though it wasn't really safe. The human, the therapist said that no, the answer is not safe. We then built an agent to actually go and retrieve data, from, for example, like a textbook of mental health, and go retrieve from NIH and so on. It helped a lot. You see, this agent is much closer to the human expert, but still overestimating a little bit. So this is actually, I would say, my last slide. I just put the links for many of these things I just presented. The pipeline for our PPG agent, the OpenChat agent, Centaur platform, PG processing pipeline. So please feel free to also look at these sources. And thank you so much for your time.
I can speak very loudly. It's a great talk. I see tons of application in the clinical area. In fact, I really love that you're using dynamic information from wearable sensor to empower patient to take the decision. But there is sometimes a risk. What about false information from these sensors, and how do you manage those kind of false information to not giving a recommendation that it's not accurate, and when is the time that you may decide to escalate to human rather than AI?
But that's a great question, and that's like an example of garbage in, garbage out, right? If the data is like not reliable, and again, I would argue that exactly for the same reason we need agents for safeguards. For example, data coming from these external sources, it can be variable, it can be EHR, as you mentioned, it can have some false information. I think building, how to say, I don't want to call it filter, but models can pre-process, curate, or even having a human in the loop before we feed that data into the model. Again, that's part of an agent, yet you need to add another stage to an agent. Rather than directly let the data go to your models or to whatever, then you can have actually another stage in your pipeline to kind of maybe, as I said, it can be an external model, which we actually, we have also a paper tomorrow with constitutional AI. So you can also build guardrails before letting your kind of model ingest that type of. You're absolutely right, a lot of outliers, a lot of things. So you need to first do your homework, hopefully automatically, but if not, through a human in the loop process, maybe flag certain outliers and ask the human to kind of confirm, something like that, and then let that data go to the system before we just allow garbage in garbage. I don't know if it answers your question.
That's great. I was wondering that whether there is a way to look at the contradictory facts. For instance, in healthcare, we have fragmented care. Yeah, let's say that for diabetic ulcer, we have vascular surgeons seeing the same wound like podiatrists, infectious disease. But for instance, podiatrists may say that it's ischemic wound, but vascular surgeons say it's not. So already we have two contradictory facts that is coming. And in actually Agentic AI that trying to use it is happening, and that causes denial of insurance for reimbursement. So yeah. I believe that somehow there should be some model that also evaluate that whether that makes sense, that is contradictory with the other information that we have, and maybe analyzing those contradictory and then make it an informed decision guidance.
Interesting, yeah, of course. One, just the first thing comes to my mind, it's like you have those contradictory kind of inputs, right? And now you have an agent which can, like a deep search that GPT-4 has, go and spend some time, we could, time, maybe not days, maybe some minutes or hours to dig in, look at the knowledge, like compare with other cases. So you let it, it has two kind of viewpoints, and now you let it to be the judge and go and see which one is more appealing with result, with explanation, not just yes or no. So that I think this clinician A is more probably correct because of this and this and this I found, and maybe you show that evidence. I think that it has to be like a collaboration, a co-pilot, if you will, not a decision maker. We don't want to delegate everything to it. Having a co-pilot for these things might be just the first thing came to my mind, but of course there are many other ways to look at it.
All right, let's thank Amir again. There are actually a handful of questions still for you, but I think we'll take them in the break here. But before we step out to the break, I also want to give 5 minutes to one of our sponsors, Looks. They're going to tell you